Welcome along to our next video tutorial where we are learning how to create Minecraft worlds using Python code. In this video today we are looking at creating a forest of trees, which is a pretty big step up from what we learned in our previous video where we learned how to make one tree. We're now going to be making 50 of them. And we're going to be learning something new today as well called functions. So instead of actually writing out the code for 50 different trees, which would take an awfully long time and be a lot of lines of code, what we're going to be doing instead is creating something called a function, which is a reusable snippet of code. So we're just going to write the code once to draw one tree, and then we're going to reuse that code another 49 times basically to create 50 trees. So let's get started on creating this today by jumping over to our Python editor. I'm using Mu, and I want you to type in the usual 4 lines of code that we put at the start of each program. So the first line of code you need to put in is the one that imports all the functions from the Minecraft library to allow us to actually code up worlds in Minecraft. The second line of code is the one that gets the 2 programs, both Mu and Mu and Minecraft, a bit of a tongue twister there, talking to one another. And finally, I want you to put in the 2 other lines of code that clear our world off so that we've got an empty slate each time we run our code. Once you have got that all set up, we are ready to go. So the first thing I'm going to do, and you should be getting used to this next line of code as well, is getting our player's spawn point sorted out. So where do we want the player to appear when we first run our code? So I might put in a comment here that just says set the player spawn point, and we do that by writing mc.player.setPos, and we open up some brackets. Inside of those brackets we need to put in the x, the y and the z coordinates. So today I want to start at -5 on the x-axis, 1 for the y-axis which has us standing on top of the grass, and then -5 for the z-axis. So when we spawn, we're basically just standing a little bit outside of the forest. Once we've got our player spawn point sorted, we need to set up the coordinates for where we want our first tree to start. So where's our forest going to begin? So I'm going to put in a comment that says forest coordinates. Coordinates, I left the n out. There we go. So it's basically the starting coordinates for the forest, and we're going to just set it to 0 for all of these. So x will equal 0, y will equal 0, and z will equal 0. So it's going to start smack bang in the middle of our Minecraft world. After we've got the coordinates set, we need to tell Minecraft what materials we're going to be using for our trees. Now that's pretty straightforward. We did this in the last tutorial. So we are using wood for the trunk, so that's number 17 on the block ID sheet, and we're using leaves, which is block 18 on our ID sheet there. So I want you to write in a comment that says materials, and we're going to just list the trunk as number 17 and the leaves as number 18. So remember here we're making variables which are like buckets that hold information. So we've made a bucket called trunk and a bucket called leaves. Inside of those buckets we've got the number 17 and the number 18, and we'll reuse the trunk and the leaves buckets a little bit later on in our code. So that's basically everything we need to get started. We've got the player's spawn point, where the forest is actually going to start being built from, and the materials we need to build the trees or the forest themselves. What we do now is we get into the tricky stuff. Okay, first up, we need to write in the code for one tree. We're going to do it slightly different to what we did in the previous video. You heard me mention early on in this video that we're going to be creating something called a function to help us repeat our code multiple times. So let's do that now. What we're going to be making is a function called tree. And inside of this function, which is just a little snippet of code that we can reuse, we're going to put the code to draw one tree. So to make a function, you first of all need to give it a name. So we need to define a function. So we write in the letters D, E, F, and we give our function a name. Because I'm drawing a single tree, I'm going to call my function tree. And then in brackets, I want you to write x, y, and z, and then close the brackets and put a colon at the end. The reason we put the x, y, and z there is it's just going to be using these coordinates here inside of this function, so we just need to make sure we call up those coordinates and just put them here so that this function can use them and it knows where to actually draw the tree. So we've defined a function. I better put a comment in here that just says code to draw one single tree. Okay, so we've given our function a name called tree. We put a colon at the end here, which is really important. If you press enter now, you'll notice that your mouse cursor becomes indented, which means it's been pushed across from the left-hand side of the page. And that's important in Python, just to tell it that the following code is what is going to be inside of this function called tree. So what we need to do now is basically use the same code we used in our previous video to draw a tree. So we start with the trunk. If you want to copy and paste this from your previous tutorial, by all means go for it, but I'll just write it again. So it's mc.setBlocks, and we just put in the x, y, and z coordinates, 0, 0, 0, for our starting position for the trunk. And then for the end position for our trunk, it's going to be, I think it's the same for the x and the z. It's just the y that needs to go up 6. So we just do another x, y plus 6, and then a z. And to finish off with, we need to tell Minecraft what material we're using to build the trunk. So remember, we're using number 17 on the block ID sheet, which we labeled trunk. So let's just write in trunk there and close our bracket up. On the next line down, we're not going to write build, we're just going to write leaves. So we now need to put in the 2 lines of code to draw the 2 layers of leaves. Remember, there's a bigger base layer of leaves and then a smaller layer of leaves on top of it there. So let's add this code in. Again, same as what we did in the previous video tutorial. So we do mc.setBlocks, do x minus 2, y plus 6, and then z minus 2. And to finish off with here, it's going to be x plus 2, y plus 6, and z plus 2. And we need to put in the material we're using, which is leaves. So we can, I wonder if we can copy and paste this. I reckon we can, because we only need to change a couple of numbers here. So if you want, copy and paste that line of code straight below. And instead of doing x minus 2 and z minus 2, I want you to change it to x minus 1 and z minus 1. Where you've got x plus 2 and z plus 2, make it x plus 1 and z plus 1. The other thing you need to do is just change the y value so that we build up another layer. So change the 6s there to 7s. So carefully check that second line. If you did copy and paste, it should say mc.setBlocks. We've got x minus 1, y plus 7, z minus 1. They're our starting coordinates for this top layer of leaves. To finish off with, it's x plus 1, y plus 7, and z plus 1. And leaves were our material, of course. Now, if we were to save this code, make sure you save it as number 9 forests, and give it a run, we should get an empty world. But that's it. Even though we've got the code, I know they saw some trees a second ago there, but they disappeared. It was just the world clearing off. I'm spinning around in circles here. I can't see any trees. So even though we've put in the code down here to draw a single tree, it's not actually going to show up on our page until we call up this function to be used. So remember, our function's called tree. And if we want to see a tree actually appear on the page, we actually have to write the word tree, bracket, bracket. Okay, just like that. And that goes back and it finds this function called tree and it runs all of the code inside of it. So if I was to give this a run now, oops, we forgot to write the x, y, and z in the brackets there. X, y, and z. My mistake. We'll give that another run. Now, if I spin around, we've got our tree. Okay, so if you want a function to actually run, so all of this code inside of a function, you need to call it up. So I had to call up tree just to make all of this code run. That's not how it's going to work today, so we're actually going to delete that line there and make ourselves a bit more room. I'm going to keep going down here. So we've got plenty of room. So we put in a function to draw one tree. What I want to do now is draw a row of trees that has 10 trees in that particular row. And to do that, I'm going to make another function. So I'm going to call this function, I'm going to call it row. And I'd better give it a comment first of all. So I'll just write code to draw 10 trees in a single row. Okay, so this function name is called row, and again we need to pass in the coordinates of x, y, and z. Otherwise we won't know where to build our row of trees. Make sure at the end, once you've closed your brackets off, you put a colon. It's really important you put those two double dots there, the colon. Otherwise your function's not going to work properly. So in this row, what we're going to do is we're going to create something I don't think we've used before, called a loop. So we can get the computer to repeat something, which is known as a loop, time and time again with very simple code. It looks like this: for I in range 10. I don't know what I just pressed then, but my theme changed color. Let me just go back there. So for I in range 10 is the computer's way of saying I want to repeat some code 10 times. And if we put a colon at the end and press enter, you'll see your mouse cursor becomes indented again. And this is going to tell the computer, hey, this is the code that we want to repeat 10 times. Now I know this is getting really confusing. So let's just keep working along, and hopefully it makes a little bit of sense as we go. So what I want to do is I want to draw 10 trees. So instead of writing out the code up here 10 times to draw a tree, all I need to do is call up that function called tree. And remember, we just need to put the coordinates in the brackets, x, y, and z. So the computer now knows we're going to draw 10 trees simply by writing that there. It sees the function called tree and it goes back up here and it runs all of this code inside of that tree function 10 times. And if I was to give that a run, nothing would happen. Okay, we're not quite finished yet. If I did call up this function called row to run, what it would do is actually build 10 trees on top of each other. We actually haven't told it to move further along in our world to draw the next tree. So that's our next line of code. What we're going to write in is x equals x plus 6. So it takes the current x value, which I think is 0 up here, and it adds 6 to it. So there's 6 blocks of space between each of our 10 trees now. So that is all we need to add in to draw a complete row of 10 trees. Alright, so let's, I guess, give it a test and see if it works. So what we need to do is call up this function called row. So if I write in row x, y, z and close my bracket up, let's see if this works. We'll give it a run, and bang, all of a sudden we have a row of 10 trees. I'm just going to go for a fly to show you that. And each tree has a gap of 6 spaces between it, so they're perfectly spaced out. Okay, I know this is super confusing, but if you just keep copying what I'm writing, that's going to work. Now I don't want to leave that line of code there, the row x, y, z. I want to delete that. And what we're going to do now is create the forest itself. So we're going to create another 10 rows like this. So in total there's going to be 50 trees. So here comes the last little bit. We need to reset our x coordinate first back to 0. So reset x coordinates. Oops. Alright, so let's put in x equals 0, because as we built this row of 10 trees, remember our x value changed, so our x coordinate changed. It went further along the x-axis all the way to wherever it ended up to draw that final tree. What we want to do is reset it back to the start up here so we can draw the next row of trees. Okay, that's the reason why we reset our x value there. So once we've reset that, we're just going to create a loop. So it's another one of these ones. For I in range. And I'm going to put 10 in brackets and put a colon at the end. Remember, this is the line of code that tells the computer we're about to repeat something 10 times. It doesn't have to be 10 times. You could do 5 times, for example, or you could do 50 times. Just depends how many trees you want in your forest. But to keep it simple, I'm going to stick with 10. I don't know why my theme keeps changing color there. I must keep bumping a button. Alright, so for I in range 10, what do we want to repeat 10 times? Well, we want to repeat this function right here, the row function. So just write row, then in brackets x, y, and z. So it knows the coordinates that it's starting with. Each time that we run this, we want it to move along the z-axis. So we're going to be moving our forest, basically, I don't know if it moves left or right here. I think it's going to be moving right. So what I need to do is write z equals z plus 6. So each time we draw a row, it draws a row of trees first of all, so 10 trees. Then it moves along the z-axis 6 spaces. And it repeats that line again to draw another 10 trees. It moves along another 6 spaces and draws another 10 trees. And it does that 10 times, so we get 10 rows of trees in total. But that's it. Super confusing, I know. We've learned a lot today about functions, and we've also learned about loops. I might actually put a comment in here that basically says draw the forest. So 10 rows of 10 trees in each. So we're going to end up with 50 trees in total. Let's have a look. We'll give it a run and we'll see what happens over here. There we go. There's our forest. So if I just fly in the air, if it lets me. Okay, we've got our first row, remember, of 10 trees. That's what we started with, this first row just here. And then by putting in that last line of code, saying that we want to repeat it 10 more times, we get another 10 rows of 10 trees. So we get this awesome big forest. I'll just jump back to the ground. It looks quite cool from underneath. And that's it. So if we just jump back to our code, we can quickly look over what we've learnt today. You already know how to do all those start bits. You know how to set the player's start position, how to set up where the forest is going to begin. You know how to use the materials. It's down here where it got tricky. And we started looking at functions. We've got 2 functions here. Remember, functions, I want you to take this away with you when this video finishes. Functions are just little snippets of code that we can reuse time and time again. It saves us having to write it out multiple times. So remember our first function? It was called tree, and it just had the block of code in it to draw one single tree. The second function that we created was called row. It made a row of 10 trees, and the way it did that, it used something called a loop. Remember this line here, for I in range, you will use it a bit more this term. For I in range is what we call a loop. It's repeating something 10 times. Okay, and it repeated our tree code 10 times to draw 10 trees. So that made one single row of trees with 10 trees in that row. To finish off with, we just did another loop where we repeated that row of 10 trees another 10 times. So we got 50 trees in total. Alright, probably doesn't make a lot of sense to you right now, but the more we practice this, the more we work with functions and the more we work with loops, the more it's going to make sense. So even if you don't understand this at all right now, stick with it. Just copy what I've written, and as we do more tutorials, it's going to make a lot more sense. Okay, so I'll catch you in the next video where we can have a bit more practice at doing just this.